Chapter 9, Momentum and its Conservation. What we're going to cover today is Section 1 on impulse and momentum. We're going to start off with impulse. Your definition is that it's the average force and the time interval that it occurs in. So for example, you have an object, there is a force being applied to that object. The time that it takes for that force to be applied, that's your impulse. So impulse can be represented by the letter J. You'll see that later on in the formula. And the units for impulse are newtons multiplied by seconds. So that's just the force multiplied by the time. Okay, so there's no new units here. We're just combining the two. So finding impulse, J, that's our I, that's our impulse that we're finding. The formula is F delta T. So force multiplied by the change in time. Now, you won't always have a change in time. I may just give you that it takes 21 seconds. Or I may tell you that you start at 5 seconds and go to 10 seconds. Then your change would only be 5 seconds. So keep that in mind, just like we've done since the beginning of the semester. So J, that's your impulse, newtons times seconds. F, that's your force in newtons. And T, that's your time in seconds. Now before we do any examples, let's go ahead and talk about momentum. That's the mass and the change in velocity of an object. So every object has a mass, but momentum depends on the velocity of that mass. Okay? So momentum is going to be represented by a lowercase p, and the reason is because the other letters were already taken. Okay? So lowercase p is our momentum, and the units, again, we're just combining the units the way they are. So kilograms, that's our mass, multiplied by meters per second. That's our velocity. Okay? So units here are pretty straightforward. So how do we find momentum? P, that's our momentum, equals mass times the change in velocity. So again, momentum, that's kilograms multiplied by meters per second. Mass should always be in kilograms. If it's not, you should convert. And velocity should be in meters per second. Again, if it is not in those units, you need to convert. So let's go ahead and talk about what's called the impulse momentum theorem. And this is going to be very important for you to know. When we're doing examples, what you should know is that the impulse is equal to the change in the momentum. Okay? So an object, let's say that you have a baseball. It's being thrown toward the batter, and the batter's going to hit that ball. Well, the object, that baseball, has a mass, it has a velocity. But it changes all of that mass and velocity into impulse from momentum when the bat connects with the ball, because you now have a force being applied to that baseball. And there's a specific set amount of time that that baseball is in contact with that bat. That piece is your impulse. And then once they disconnect, once that bat is no longer touching the baseball, it converts back into momentum. So nothing is being lost here. That's what conservation is that you are conserving what you had to begin with to what you have at the end. Okay? So impulse is actually equal to your momentum. So F delta T is equal to P, your momentum, or we can just skip the P part and say that F delta T is equal to mass times velocity. Now let me show you an example of how we're going to use this. So let's first say, for an example, a 2,200 kilogram SUV is traveling at 94 kilometers per hour. That's about 26 meters per second. It can be stopped in 21 seconds by gently applying the brakes. So I want to know what's the average force that's exerted on the SUV. Okay, we have F delta T, we have MAV, or M delta V. Okay, some students like to refer to it as FAT and MAV. So F delta T, that's our impulse. We could find that if we wanted to. Okay, because we have M delta V. I gave you a mass, I gave you a velocity, but I also gave you a time. So what I want you to do is plug those things in so that you can find the force. We're looking for F. So 21, that was our time. 2,200, that was our mass. And 26 was our velocity. So let's go ahead, just move everything around. I like to keep everything nice and in parentheses. Okay, that way we make sure we're doing things right. Calculator's not going to get it wrong that way. So F equals 2,200 multiplied by 26. And then divide by 21. And the answer you get should be about 2,723.81, or 2,723.81. And again, that is force, so it is in newtons. There are some practice problems in your textbook, and I do want you to go ahead and do those. You will actually do those on the back or on a separate sheet of paper, and I'll have you turn those in at the end of class. So page 577, do questions 1 through 4, and that's all for today.